Okay, good morning, chemistry students. I am trying something I've never tried before, so we'll see how it works. I am wanting to be able to do the Module 8 test review with you, and I'm not going to get to see you, I guess, until next Tuesday, so I want to go ahead and let us do the review. So what I'm going to do, I think, is do a couple of videos. This one is just going to be the definitions and the things like that that you have to know. And then I'll try to do some videos where I have, I work the problems out. And so what I want you to do is watch them all and then FaceTime me, call me, or whatever you'd like to do if you'd like me to work with you through some of these problems. Okay, so first I'm just going to go through, like I always do, the definitions and the things like that that you're going to need to know for the test. So as I'm doing things with you, I'd like you to actually, if even needed, pause and try to answer it yourself, where you're not just writing down what I say, but you try to think, do I know this? Okay, so the first thing is you have to be able to define stoichiometric coefficient. Okay, so think about if you know what that is. And what it is the number that is to the left of a substance in an equation that describes the ratio of one substance to another in moles, which is what you're going to be using throughout this chapter to be able to do all your problems. Okay, so that's the stoichiometric coefficient. It's the number that, like if you have 2 NH4, the 2 in front is your stoichiometric coefficient. Okay, then you have to also know what stoichiometry is, which should go along together well. That is relating the quantities of different substances in a chemical equation. That's what we use to be able to say that 2 moles of water relates to 2 moles of NH4 or whatever. Okay, that's stoichiometry. Okay, you're going to also have to be reminded of what the limiting reactant is, and we did that the other day with we kind of got the idea using the cars and the wheels, you know, the body versus the wheels, and the limiting reactant is it is the chemical that is responsible for stopping a reaction. In other words, once that is over, the reaction stops, and it also is responsible for determining how much product is actually produced. We use the example in class, like if you have 2 bodies but you have 10 tires, the bodies are your limiting reactant. You can only have 2 products. You have 2 wheels left over, but it doesn't matter because the bodies was the limiting reactant. So you're going to have to know that it is the chemical responsible for stopping the reaction and also for determining how much product is produced. Okay? You're going to be able to define empirical formula, know the difference between empirical formula and molecular formula, and then we'll do some problems on the next video about that. Okay, so an empirical formula is the formula which indicates a simple whole number ratio for the atoms in a molecule. In other words, you've gone to your least common multiple on all of the parts of that compound. Okay, and so like I said, we're going to do some examples and that'll help you know more, but you'll have a problem where you have to actually state what that definition is. So also another question is going to be, what is needed to convert an empirical formula into a molecular formula? And we're going to do some problems like that, but you're going to have a question that actually asks, and so what is that? Think about that. What is the thing that you have to be able to convert that? I'm giving you time to think. Okay, you have to know the mass of the molecule that is involved, and once you know the mass, then you can change it from the empirical formula to the molecular formula. And you're going to have a problem like that on your test. So we'll do some examples like that. Okay, and the last definition type thing that you'll have to know for the test is the Gay-Lussac, I think is how you say the name, law and its limitations. Okay, so think about, we talked about this in class the other day. That is where stoichiometric coefficients can be used to relate volume of gases in a chemical equation. So just like whenever we use stoichiometry, we can say 2 moles of this product is used to 1 mole in this equation. Well, you're able to do that with gases in liters. But the limitation, it is only in gases. You cannot use it with liquids or solids. It can only be used, so that's the limitation. You have to be able to state the law and its limitations. Okay, so I don't know if this is going to work or not. We'll try it out, and then I'll do some examples on the next videos. Okay, thanks.